Yes. Welcome back to Around the World in 80 Telescopes, a live 24-hour webcast that is part of the 100 Hours of Astronomy project for the International Year of Astronomy. You've been joining us at the European Southern Observatory headquarters near Munich in Germany, and we've been visiting some of the most advanced telescopes both on and off the planet. Before we go to our final stop, I just want to remind you that if seeing all this has whetted your appetite for astronomy, you can continue with the 100 Hours of Astronomy event. It's going on until Sunday. Just visit the website at www.100hoursofastronomy.org and you can find public events near you. But now we're going to our final stop in the webcast. It's the famous Palomar Observatory in Southern California. Before we join them live, let's find out about them in this video.
The California Institute of Technology's Palomar Observatory is located in the rugged wilderness of Southern California. It is home to three principal instruments: a 60-inch telescope, The California Institute of Technology's Palomar Observatory is located in the rugged wilderness of Southern California. It is home to three principal instruments: a 60-inch telescope, the 48-inch Samuel Ocean Schmidt telescope, and the 200-inch Hale telescope, which for decades stood as the largest telescope on the planet. In 1928, astronomer George Ellery Hale secured a $6 million grant to build the 200-inch telescope that would later bear his name. The site for the observatory was chosen in 1934. Building the telescope was a mammoth project that spanned both the American Great Depression and World War II. Construction began in 1936 of an 18-inch Schmidt telescope and the dome for the 200-inch telescope. The massive parts for the 530-ton telescope were constructed by Westinghouse in its South Philadelphia plant. After one failed attempt, the 200-inch telescope's giant Pyrex mirror was cast by the Corning Glass Works in New York State. The 20-ton disc was allowed to cool for 10 months before it was ready to transport by train to Caltech in 1936. There it was in the optical shop for 11 1/2 years. Assembly of the dome and telescope was completed by the late 1930s, but the mirror did not arrive to Palomar until after World War II. Finally, in 1949, it was time for the Hale telescope's scientific mission to begin. Along with the 48-inch Schmidt telescope, it helped astronomers to rewrite the astronomy books as the universe began to give up its secrets. Astronomers mapped the northern skies, probed galaxies, and discovered the first quasars. Closer to home, discoveries such as Comet Shoemaker-Levy 9 give us a new perspective on the dangers within our own solar system. The discovery of dwarf planet Eris knocked Pluto out of the solar system's planetary roll call. The small telescopes at Palomar are used nightly for dedicated research programs. The wide-angle Samuel Ocean telescope is undertaking a survey of the night sky for transient sources, while the Palomar 60-inch performs follow-up observations. Caltech is currently partnered with the Jet Propulsion Laboratory, Cornell University, Oxford University, and the American Museum of Natural History. Astronomers from those institutions share the Hale telescope's observing time. Astronomers no longer ride in the Hale telescope, as Edwin Hubble did. Sensitive electronic imaging and spectrographic instruments have taken their place. Technicians install and maintain the instruments in preparation for each night of observing. New instrumentation on the Hale telescope makes use of adaptive optics technology. Adaptive optics is a technique that allows ground-based telescopes to remove the blurring effects caused by Earth's atmosphere. This image shows the dramatic improvement gained through the use of adaptive optics. On the left is a blurred image without adaptive optics corrections, and on the right, the corrections reveal a binary star. By projecting a laser into the sky, astronomers can create an artificial guide star for use in adaptive optics. To do so, they shine a narrow sodium laser beam up through the atmosphere at an altitude of about 60 miles. The laser beam makes a small amount of sodium gas glow. The reflected glow from the gas serves as the artificial guide star for the adaptive optics system. The Palomar Observatory crew works tirelessly to maintain the aging Hale telescope in various ways, including periodically pulling and recoating the 200-inch mirror. Caltech and its partners continue to devise new instrumentation for the Hale and the other telescopes of the Palomar Observatory, ensuring that our mission of converting starlight into knowledge will persist for years to come.
We're now going live to our final stop, the famous Palomar Observatory. Hello, Palomar.
Hi, Douglas.
Hi.
How are you doing, Douglas?
Good, thank you. We're a little tired here, but we've survived.
I'd actually like to extend my congratulations to you and the whole team at ESO. This has been a real marathon for you guys, I know, and it looks like things have gone pretty well.
It's gone pretty smoothly. That's Scott I can see there, isn't it?
Yes.
Could I ask you to introduce yourself and then perhaps just to introduce the other people that you have with you in the room?
Sure. I'm Scott Cardell. I'm the Public Affairs Coordinator here at Palomar Observatory, and I'm joined by our three observers right now here at the 200-inch Hale telescope. We have Nick and Olivera and Gwen.
Hi everyone.
Hi there.
Hello.
So we saw in the video some of the history of Palomar. It really must be an amazing site to be at. Could you tell us a little bit more about it and about the location?
Well, we're located in the mountains of Southern California, near the city of San Diego, and Palomar Mountain was chosen as this site back in the 1930s, and they began construction on the telescope in 1936, and it was a big project that actually took a long time. So it spanned the American Great Depression and World War II, and didn't get finished until afterwards. And as you probably know, it's a huge telescope, and the dome is so large that when you walk in, it's actually a very impressive sight.
It's absolutely wonderful. And as we saw, there's it's not just, of course, a historical site. There's still cutting-edge research happening there. So could you share with us what you think some of the highlights are of that research?
Well, we've got a lot of things. It's kind of interesting that one of the big early discoveries at Palomar was the first identification of quasars, and the fact that quasars were at these large cosmological distances. That was a discovery made in the early 1960s. And as it happens, tonight our observers are using a near-infrared spectrograph. And Gwen, I believe you told me that's what you're here studying tonight is quasars.
Yeah, we're studying high redshift quasars at redshifts or Z's of about 2 or 3. So these are massive black holes that are accreting matter. And so they're very, very bright, and we can see them from very large distances.
And you're actually observing them right now?
Currently, no, but we're opening the dome to observe. We had some bad weather, so we had to shut it for fog, but we're opening up right now. And yeah, the really interesting thing about this kind of research is we're actually studying light that was emitted by these objects, something like 11 billion years ago. So it's kind of cool stuff.
That's wonderful. So the weather was bad earlier, but it's improving now, and you're just getting ready to start observing. Is that right?
Well, we've had a bit of both, actually. So it was dreadfully foggy during the daytime and reasonably good early in the evening, and I think you got about an hour of data or so on a quasar, and then they had a radio transient that was called in, and they observed that for some time, and then the fog rolled back in.
And what do you mean when you say a radio transient?
Well, basically a transient is something that comes and goes, or something that flares up in brightness or varies in some fashion. And when we have other observers that detect these, in this case using radio telescopes, they would want to be able to try to get a spectrum on the object. And so the near-infrared spectrograph that we have on the Hale telescope tonight was called into action, interrupted a bit of their time, but I think they were reasonably nice about it, and went ahead and got the spectra on this object that flared up in the radio wavelengths.
And so do you know which radio telescope it was that triggered you to have to interrupt your observations?
Did Ashish say no?
I was just
but we can
wondering
thank
if it might
Ashish
have been one of the
Mahabal for
people we
that.
visited earlier.
Yeah, I don't actually know.
No.
Okay.
No. They just tell us where, they don't tell us where from.
Oh, wow. And you were saying that you had some problems earlier in the evening. I've realized I'm not actually sure what time it is there now. We've been here for, well, actually over 24 hours now. So what time is it where you are?
So I guess I shouldn't complain about personally being tired. It's about 12 after 2 in the morning here in Southern California.
Okay, okay. And I understand that you actually have an astronomical image that you have ready to share with us.
That's right. Because we're doing near-infrared spectroscopy tonight, we have a near-infrared image that was taken with a different instrument here at the Hale telescope. This is an object known as Sharpless 106. It's what some people would call a giant molecular cloud, something kind of similar to the Orion Nebula that more people might be familiar with. So it's a large cloud of gas. It's in the process of forming a star cluster.
You said it was called Sharpless? Sharpless 106?
Yes.
And so where did these names come from?
Well, Sharpless was someone that made a catalog of these things, and it's number 106 in his catalog. It's not as poetic a name as things like Andromeda, but it as far as I know, doesn't have any other sort of common name to go with this object. But it certainly is a striking object, at least in the near-infrared.
Okay. And so you're saying that you're making these observations, or you're planning to be making some observations now. How long will you continue during the night if everything goes to plan?
Well, the plan is each and every night to observe essentially from sunset to sunrise. And you folks, you actually have, is it 4 nights total? Three, I'm sorry. So they have 3 nights. So tonight is the first of a 3-night run. And the weather is expected to be much better for tomorrow evening and the evening after. And then they'll go home back to Caltech in Pasadena, and a new team of observers will come in and proceed with other observations and probably entirely different set of targets.
Well, let's hope that you have good weather for the rest of the run. I understand that this year is actually a particularly important anniversary for the Hale telescope. Isn't that right?
Yeah, so we're not just celebrating 400 years of Galileo using a telescope. We're actually celebrating the 60th anniversary of first light on the 200-inch here at Palomar. So it was in January of 1949 that Edwin Hubble first used the telescope to take pictures. And of course, his observing experience was pretty different from the observing experience that these folks have.
In what way?
Well, back in Hubble's time, people had to ride in the telescope. And so on a night like tonight, where currently it is 0.7 degrees C above freezing, the astronomer would have to be up high in prime focus for maybe 10 hours or the entire night.
So they would actually be suspended above the mirror? above this huge mirror?
Yeah.
In some sort of
right.
What,
so
in
you don't
a
want
cage or something?
Yeah. So there's a called the prime focus cage. There's a chair in there that would swivel around so that you wouldn't have to be falling out of it. And there are rumors that people would take two thermoses with them, one for liquids in and the other for liquids out.
Well, that's something we haven't had to resort to here yet, at least.
But they also used to wear these World War II surplus flight suits that had electric coils in them, so they could plug them in, and it's kind of like an electric blanket you could wear. I think that would keep the astronomer a bit more comfortable, but probably be really bad for seeing. You'd get this warm rising air coming up right through the optical path of the telescope. But given the choice of freezing to death or slightly reduced visibility, I guess they chose being warm.
So it's lucky that we've had these advances in technology to make sure that we don't have to do this kind of thing before. I think probably we shouldn't complain here, even if we've had to be awake for so long, because at least we haven't had to do it with flight suits on. But that's absolutely fascinating. So another thing I was wondering is, what other outreach events does Palomar have planned, either for the 100 Hours project that's just coming to an end on Sunday, so it's not quite done yet, or for the rest of the International Year of Astronomy?
Actually, starting, well, I was going to say tomorrow, but it is tomorrow. So starting later today, we offer tours to the general public, which we'll do Saturdays and Sundays during the daytime, where people can come in and get a close look at the telescope and get a guided tour, and someone will explain how it was built and what it's used for and how it works. And we'll do these every weekend now all the way through summer and into fall. And tomorrow, personally, or again later today, personally, I'll be at something called the San Diego Science Festival, showing people the sun through a small telescope. And when the moon rises again, I'll show them the moon through that too.
And so if people want to find out more about this, where can they find all of the details?
A good place to do that would be at the observatory's website, Palomar Observatory, palomar-observatory.org, or even the blog I do for the observatory, palomarskies.blogspot.com. I put a lot of cool pictures that people like this take, and pictures of the dome at night. In fact, before the fog rolled in, I took a picture outside tonight and posted it on the blog while I was waiting for this to happen.
Wonderful. So people can follow all of this up online. Well, thank you very much for taking the time to speak with us, and thanks for being willing to wait a little bit. I hope that your observing goes fantastically for the rest of the night and indeed for the rest of your run. So thank you very much, Palomar, and goodbye.
We appreciate it.
Thank
and
you.
Happy International Year of Astronomy to you and everyone at ESO.
Thank you.
And hi
Bye-bye.
to everyone back at Caltech that's watching.
And Varun.
Bye.
Bye.
Have a good night.
Good night. And so this brings us, after 24 hours of webcasting, to the end of Around the World in 80 Telescopes. You've seen state-of-the-art observatories all around the planet and in space. And it's fitting for us to close with this visit to Palomar, which has played such an important role in astronomy. We hope that by watching even just a little of the 24 hours, you've managed to get a view of the wide range of telescopes and observatories of many different kinds that exist, and the many ways in which today's astronomers are discovering fascinating things about our universe. We'd like to thank everyone involved at all of the observatories, and also the webcast team here at the ESO headquarters in Germany, not just the hosts, but the many people who've been working extremely hard behind the scenes for months. We'd also like to thank you, our viewers, for joining us on this amazing journey around what a wonderful surprise, around the world in 80 telescopes. Goodbye.
Bye.
Can we bring everyone in and then go back live?
For the eyes of the world, now look into space.
That's one small step for man, one giant leap for mankind. There seems to be no difficulty in moving around this